Hopefully. Hi, everyone. I know we are the last session before lunch. We won't run too late, don't worry. So let's see. Who remembers Log4Shell? Hopefully everybody. And it was a bit like the thing where in December, mid-December, Log4Shell hit. And we were all kind of ready, I think, for Christmas more or less. And then somebody decided to join the party and it changed how things were working out a bit. I normally run the poll like, what logger are you using if you're a Java audience, but I'll skip that for today. I still have another poll. If you go to slido.com and then Xera, which is also my Twitter handle and everything, or you just scan the QR code, you can fill out the poll. I'm just curious to ask anonymously who was affected by Log4Shell, because nobody wants to raise their hand and say that publicly that we were affected. So I'll let you fill that out anonymously. Also there, if you have any questions at any point in time, you can just type them in, and I'll come back to those later. So if you don't want to shout, we can also do that. You can just raise your hand and ask in person, of course. But if you type in any questions, I will come back to those, and we'll see how that's going. So let's see. So I see that we have a 50-50 tie. And, well, I guess it keeps switching. Cool. So I see that we had a whatever share of distribution we had. I'll put that up one more time. So if you haven't joined yet, you can still fill it out. We can take a look at it at the end, like who was affected and who wasn't affected. But let's jump right in and see what's going on. So when I was asking at a recent event, like who is using Log4j2, that was the one that was affected. For the Java audience, like that was the most commonly used logger. There are some alternatives. Some still use println, and others are what is logging. And in that case, actually, what is logging was a good thing because you didn't have that security issue then. But overall, probably not what you want. So I have broken this down into like 4 parts. What even is Log4Shell? How can you exploit it? How can it affect your products? And how can you protect against that? And well, let's dive right in. Why am I talking about that? I work for Elastic, the company behind Elasticsearch. We have used Log4j2 and have, because of that, dealt with Log4Shell a lot. So we have that all in our product. So I spent a large amount of my December on Log4Shell issues. So what even is Log4Shell? So those who have kids who play Minecraft, they might have come up with that question, and you can then give them a very long explanation of why there was a Log4j update and what it means. And we can take the entire day or night to explain like where this is coming from strings in C down to jar files, but we'll do the compressed version of that, I think. So what happened was there was this update coming out, I think it was Thursday night, our time, when somebody said like, oh, there's this security thing in Log4j, and everybody was like, oh, well, interesting, I'll look at it, I don't know, tomorrow or after Christmas or whatever. And then on Friday, pretty much the internet was on fire, and everybody like, yeah, we need to fix that. So what happened? Or before looking at what happened, like taking a step back, what is even enabling this security issue? So at Black Hat back in 2016, somebody said like, there's this interesting concept in Java called JNDI, the Java Naming and Directory Interface, or sometimes the Java people also call it JND, which basically allows you in your application to look up some other values from some source. And that source could be LDAP, RMI, or Corva. Most of the attack vectors are now doing LDAP. And it's basically a way to dynamically look up some value from a remote source to fetch that. Which, back in 2016, people were already like, oh, this looks like an interesting concept to exploit. And then it was very quiet until somebody rediscovered that in Log4Shell. And basically what you could do is you would give Log4j, the logger, a string like this, which basically says, use the JND plugin and use this LDAP address to fetch whatever code you find here, and then run that in the context of the application. And that's really what all was to it. And it was is a straight 10 out of 10 RCE. So that's pretty much how that worked. To take a look at how this works, and I hope this is large enough to see, but how loggers in Java generally work, like you have data coming in and you have that logger that should write out the data. And then there is a layout that defines like how should the log be defined. Like this is the timestamp and this is the log level and this is the message and whatever. So that's the layout. And then you have the so-called appender that writes it out to a destination that would normally be a file. And in the case of Log4j, it has a lot of so-called features. And one of the features is that it has lookup plugins. So you could use that dollar curly brace syntax, and then you have a plugin name and a value for that. And what it could do is like you could say Java : version to actually look up the current Java version, which might be helpful to say like, oh, this is the Java version on which this is crashing, or the Java version we are running on. And that's potentially a good thing. What then people figured out was with Jindy, which is another plugin, you can then load this remote code. And that's really all that happened. So it's a combination of a remote code execution that you load this remote code and that you also then just execute that. So it's not just loading a string, which might have been fine, but it's really loading that remote code and then executing it. So what happens is an attacker gives you a bad string and redirects you to their LDAP server under their control, gives you whatever that A thing is doing, and you execute that. And that's really the attack vector. So somebody makes your application log that bad string. It will fetch the code, execute it in the context of your application, and that's all there is to it. You can also phrase it a bit more positively because it's not just arbitrary code execution, but it's a surprise extension API, which it really is to some degree, but, well, it's not what you wanted. And then there is the big discussion, is this like more of a remote code execution or more of a serialization issue? Because to make this a bit more complex, depending on your Java version, and there are a lot of Java versions out there, loading that remote code has in more recent versions been changed to false, so it wouldn't just load remote code and execute it, but it would just fetch it and then not execute it. But there are still other ways around that, or you could still use that to trigger local code that already exists. So a new Java version is not protecting you completely against it, though it is closing some of the attack vectors in that. So it's in part that remote loading that is a problem. The other part is like, do you even execute that remotely loaded code? So that is kind of like the thing that is coming at play here. And then obviously how to get rid of that was you upgrade Log4j, and Log4j still supports JDK 7, which is very old by now, or modern versions. And so you need to update to different versions of Log4j to get to the latest version, which looked all good. And people even adopted everybody knows Little Bobby tables. Somebody adopted that to call it Little Bobby Jindy. So this is the remote code execution that you could get with that. And as we know from Little Bobby tables, you should sanitize your inputs. And that still applies for this Jindy vulnerability. The other thing that we learned personally was that most security scanners for your applications are pretty bad. Who's using a security scanner for their application? Very few? Okay. So the problem with security scanners for us mostly are that most of them just look for the version of a library and then say like, you're vulnerable or you're not vulnerable. But Log4Shell is not that simple. So what Log4Shell does is you have some options. For example, you could say format message no lookups to true, which basically says like, don't load remote code, because most loggers don't really need that. And you could set that, but most security scanners don't know that or don't take that flag into account. Also, because of the JDK version, it might not be exploitable the same way on all versions, and security scanners also don't find that. Also, the actual feature to load the remote code in the Log4j library is there is a Java class called Jindy lookup. If you remove that from the jar, you would basically remove the attack vector or the door to it. And no security scanner finds that. And we have done that, but then you have a constant fight against false positives from security scanners. So we have been answering hundreds, if not thousands of emails about automated scanners that were detecting the wrong things, which caused us a fair amount of pain over the time. So we had the first Log4Shell vulnerability, but why not a second one, because you can have always not just second breakfast, but second Log4Shell. And what happened was that the first patch that they brought out was actually incomplete. At first, they only thought that was a limited denial of service attack, but it turned out it was limited remote code execution again, because what you had to do is you had to change the attack vector from this to this, because the patch they implemented at first was looking at like, is it only doing something local? Then it's fine. But it turned out the way that this is using code or whatever is that it will ignore that. And if it sees attacker.com afterwards, it will still load the code from attacker.com. So this was a not so complete patch. The thing that makes it a limited remote code execution is that in that pattern, how to output the logs, you needed to have something called, or you needed to use this context with whatever name you give it in your log output. And then if you ever log something into this tainted variable, only then could you trigger it. So it needed a non-default output pattern for your logs, but you could still load remote code through that. Not as bad as the first issue, but still not pretty to get to that. And again, you could upgrade, or again, this one could also be solved by removing that Jindy lookup class, which we have done. And for us, it's kind of like, it's a stupid hack, but it's also kind of like effective, or you could say it's honest work by removing that, because it really closed that attack vector, because very few people actually need that remote lookup of code to execute something. It's just that, I don't want to be too harsh and say like it's an unnecessary feature, but it's something that almost nobody in the Java ecosystem ever uses. And it still opens this entire class of attack vectors. So you can do a stupid hack to actually kind of like get around that. And obviously there was another Log4Shell security issue. Because this one kept giving, and more people started looking at Log4j and all the features it had. And then they found another one. Again, you needed a non-default pattern. This was only a denial of service attack. The reason was they had recursive lookups in the patterns. So you could just kill your Java application by having a weird pattern that did recursive lookups. Here the solution was this feature they just removed, because again, nobody uses recursive lookups, or almost nobody uses recursive lookups in their Java application. It's just a full class of attack vectors that nobody really needs or uses. And it wasn't the last one. There was one more. So there was one more security issue here. This is a remote code execution, but only if you control the login pattern, because you basically needed to have a specific configuration to log to JDBC, JDBC is like the database interface in Java. So you would need to control the pattern of how to log to a database, and only could you then exploit that, so that the CVS score is a bit lower on that one. But they brought out another patch for that. From that one, there was the big discussion then, how bad of an attack is that? Yes, it's kind of a remote code execution, but you also need to be able to actually provide that custom pattern to exploit it, which then led to this discussion. If the attacker can already change your configuration files on the server, is it really still a security issue or not? And then some people were insisting, well, it's still a remote code execution, even though you need write access on the server. So to actually exploit it, you would probably have just to wait until you find somebody who can edit on your servers. So that one I think is more like not such a big deal, because it couldn't be really exploited in practice that easily. Okay. The final point here is, how many features do your loggers need? And that is even in the Java ecosystem, which tends to throw all the features on things, a bit of a debate, because they're the two main loggers that are used are Log4j and Logback, and Logback doesn't have a lot of these features. And to make things more interesting, the two groups of people who do these loggers don't get along with each other, and they constantly fight on Twitter and say, the Logback people will always say, you shouldn't have all these features. And the Log4j people are like, well, we have all these features and we're the better logger. So this is kind of like leading to these discussions, and if you should really have them, I'm not sure. But for attackers, it's a great field, because it has so many features that you could potentially exploit. And by the way, the people who found the initial security issue, they created that initial logo, and then every time they found a new security issue, they made the logo worse. And this is the final result. I mean, if we find another one, it would get even worse. So this is the final Log4Shell logo by now. And that's where we ended up. Any questions for that part so far? Did anybody type any questions in here? No. Any other questions? Otherwise, I'll move on. So how can you exploit it? There is plenty of code on GitHub to actually see that. So here I'm taking this one. Somebody wrote a vulnerable application just to show you how easy it is or how little you need in terms of exploitation, what you need here. So this is using Spring Boot, which is the most widely used framework in the Java ecosystem. Spring Boot itself by default uses logback and not Log4j, so it's not vulnerable. But if they have the option to switch out the logger, so if you have done that, then you can actually exploit it. So for the purpose of this application, we have added that. And all you need in your application is, we're having this class, and under the root URL, basically what you need to do is you need to log something that is vulnerable. And here I'm just taking the header. If you provide the header X API version, we're logging that, and that would be the necessary vector to actually get that bad string into your application and then load remote code. So any application that takes any user input and doesn't sanitize it and logs it anywhere is potentially vulnerable. An attacker will just need to find some header or some other place where they can inject their strings somewhere that the application will pick it up. So that's all that is needed with a vulnerable Log4j version. And then to exploit that the repository has an LDAP server that you can run. So from there you could fetch the payload, and then you would just need to run against your vulnerable application the curl request, where you say, here we provide that header with X API version, and then from the Jindy server up there, we just load the code, and then it will be executed, and that would then write something to the local file system to show that it has been exploited. So that's really all there is. You need to run your Jindy server, need to find the vulnerable application, provide the string that is somewhere being logged, and then it will fetch your payload, and you're done. So that's that part. Something that led to some discussions initially was like, why was there no virus, or should there be a virus or worm around that? And there wasn't, in part because every application is different, and every application is logging some different things. So there is not one general attack vector, but it is somewhat application specific what you're logging. That's why it's kind of hard to exploit that automatically. What you could see in the days after the exploits for this came out, that people were throwing their payload strings into all kinds of headers in your applications, and you would see a firework of logs, if you were logging that, where people were trying to exploit anything they could think of, like any field you could enter on the website, any header they could think of. People would try to throw in their dollar curly brace strings to somehow attack your application. But because it is application specific, it was not really easy to write a worm or automate that. Any questions on the attack? Cool. Then let's continue. How can it affect products? This is a bit where we at Elastic come in, because Elasticsearch has been using a vulnerable Log4j version basically forever. So 5.0 came out like 5.5 years ago or so. So for the last 5.5 years, if you have used Elasticsearch or any of our products, basically, we had a vulnerable Log4j version in that. But the vulnerability is actually not that simple to exploit. And I have made some tables to actually show you. So what you need is, you need to figure out what is the Elasticsearch version that you're using. And this is just a slide for 7. Then based on that, we have a specific Log4j version shipped with that. So for anything older, it was a vulnerable version. Then it depends like which JDK you're using, which attack vectors are open. So what we have done initially, the very old versions on an old JDK could leak some information, but you couldn't do a remote code execution because of the Java Security Manager, and I'll show you the Java Security Manager in a moment. With newer JDKs, you couldn't actually exploit it, and then we removed the Jindy lookup class and said that don't look up any remote values in any case. So this closed it. This version was then still flagged by all the security scanners. So we had to update Log4j pretty quickly after that to get around those security scanners. We are still removing the Jindy lookup class because nobody needs that feature. It is still just a precaution of what we're doing here. Why is this an information leak? So what you could do is you could do DNS lookups from your application and through the subdomain, for example, you could exfiltrate some secret information from the server, but you couldn't execute code. And I'll show you in a moment why. I've done the same table for 6.x, where it was very similar, where it also was not a remote code execution, but only on old JDKs and old versions, an information leak. And then on 5.x, which is not supported anymore, luckily, there it was a full remote code execution because we didn't have strict enough Java Security Manager rules in place. So there you could have both the remote code execution and information leak issue. And on more recent versions, you could set that format message no lookups to true, which basically doesn't do remote lookups. On older versions, the Log4j version is so old that it doesn't know that flag anymore. There you would really need to go into the jar file and remove that class file from the system. And if you're on an even older version, which is definitely not recommended, but then Log4j was so old that it wasn't vulnerable yet. So that kind of saved you in that area. The thing is, with all the things that you're running in your network, who knows what is the JDK version of everything? What is the logger that your Java applications are using? And is it vulnerable or not? And especially if it's somewhere in a Docker container where nobody really dares to look into it, it's very hard to figure out what do you even have running on your network somewhere. Yeah. And for example, for us, you could, on the API, you could do an HTTP request to just check the JDK version. And we're always shipping, for example, the latest JDK version. But it really is hard, especially in Docker, to know for all your dependencies what is running in them and where. Yeah. So the Java Security Manager, it's a piece of software that's interesting, but that also nobody in the Java ecosystem is using, basically. Because it's a bit hard to use, but it's really saved our bacon here. So what the Java Security Manager is doing, you could basically say in this area of code, you can use specific features or you cannot use them. And the common question from Java developers is always like, is it a big pain to use that? And yes, it definitely is. And it took us a long time and effort to get it right and structure our code correctly. But then it was totally worth it, because what we basically did is anywhere in our application, you can do a resolve, which is a DNS lookup in the end, and you can set some other options. But in our code, by default, you cannot fetch any remote code. So in the package that is logging, you couldn't load remote code. It couldn't open a network connection because your logger doesn't need to do that. We only have so that the logging or the networking library that we are using is called Netty, and only in a very few places we give our application socket permissions to actually fetch remote code, and otherwise it couldn't do a network call because the Java Security Manager wouldn't allow you. So even if you managed to get the attack vector in, you couldn't actually get any remote code. That's why it wasn't in any recent version of Elasticsearch a remote code execution, because those network calls were not allowed. And that's what kind of saved us here. And it's only in very few places where we do allow that. And because of this one here, it was the information leak. Because you could still do anywhere in our code, you could do a DNS lookup, and through subdomains, you could exfiltrate some information. But you couldn't fetch any remote code, that's why you couldn't exploit it. But almost no Java application is using that because it's such a pain. And also that Java Security Manager is going away, and we are currently working on actually replacing that with more modularization. Which was almost ironic is we wanted to upgrade Log4j for a long time, but we couldn't because something changed. It wouldn't play with our Java Security Manager rules anymore. So it's kind of like the Java Security Manager saved us, but it also made upgrades for some older versions harder. But we pushed past that, and we did manage to upgrade in the end. But it is creating a complex ecosystem. Though the Java Security Manager in general is complex, but it's quite an amazing piece of software if you have a widely used application, because you can limit where in your code can you do write operations to the disk, where can you do network calls. You can really limit the attack surface in your application if you manage to get it up and running, because that's a bit of a pain. And yeah, we're currently trying to replace it, which is its own problem because this Java Security Manager, because nobody's using it, it is being removed from the JDK. So you need to find replacements. You can also set this header or that configuration option to actually not allow lookups. We're doing that in any recent version as well, just to be extra sure, to mitigate that. What we're doing now in all our builds, so we're using Gradle as a build tool in Java. For example, we're taking the Log4j jar, and we're just kicking out that Jindy lookup class in the build. So it's not there. So that attack vector is pretty much closed for any ongoing version that we have. If you need to remove that from an existing installation, you could do that. Any jar file is basically a zip file. So with zip, you could just kick out the class file from the library where we are including it. And then this command would, for example, check, do you have that Jindy lookup anywhere in your jars? And you could potentially remove that. And that is the most effective way to actually close the attack vector in the first place. There was also an interesting thing from Amazon is bringing out its own JDK distribution, which is called Corretto, and they have a hot patch. So you basically, with Java with reflection, you close the hole. You always need to apply that at runtime, but it looks like Amazon has so many Java processes running that they wanted to have a hot patch option so that they didn't have to patch and replace all the running jars. So they could just at runtime fix that. This is not officially tested or recommended for Elasticsearch, and it was harder to get up and running with the Java Security Manager because they blocked against some calls there. But I worked with them, and they got that to work with Elasticsearch. I tested it. It works. It's still not recommended. What is kind of funny is that this patch then had its own security issue. So in April, they found that patch created its own security issue, but they fixed that pretty promptly. But it looks like everything around Log4j is full of security issues to some degree. Also, don't try to be too smart. I've seen various things that people suggested how you could avoid that. So I've seen some who say like, just don't log anything, right? And you're good. And you can actually do that in Elasticsearch. So for example, through the API, you could say on a cluster-wide setting, just set the root logger to off and it will not log anything anymore. But that's not what we recommend. If you ever restart the server and it doesn't come up properly, you won't see anything in the logs. So you probably want to have those logs in the first place. That's not really going to be a good fix. The other thing that we have seen is a bit of a YOLO approach, that people just replace those jar files with the Log4j version, which at least in the case of Elasticsearch is really just not working. So if you just update the jar, the process might not start at all. It might throw an exception from the security manager depending on the version, or it might look like it's working at least for some time. It could still break at any point in time at runtime. So we really don't recommend doing that, just replacing the jars. It doesn't work. It's not recommended. Do a proper upgrade. Otherwise it will just be a pain. And what we have seen was that our support, we had a couple of dedicated support engineers just answering Log4j support questions for weeks. And we had our own support rotation for that, which was not a lot of fun, and it just sucked up a lot of time, unfortunately. Any questions on that? Let me check. Did anybody add any questions so far? No? Good. Let's move on then. So, how can you protect against it? Some things that make this a bit trickier is that you don't really need to have the vulnerable Log4j version in your application. If you, for example, use Elasticsearch as a search engine in the background or as a logging system, it would need to, or it could be exploitable just by having the dependency in there, even though it's not directly in your application. As long as your application is handing over that vulnerable string to the search engine and it gets executed there, it would be enough. So you also don't need to be able to access a vulnerable system directly. Even if your Elasticsearch, for example, is behind a firewall and no one can access it from the outside, if your application is handing over the vulnerable string to the application, you would still be vulnerable. And as always, you can sanitize your inputs, and an outgoing firewall would have been very helpful here again, that your application cannot just do random calls to the internet because it probably doesn't need to. But obviously nobody is doing that. So, yeah. So how can you protect against that? You could use a web application firewall or anything else that blocks anything that has $Jindy, because that's probably not something anybody's ever throwing at your application, which would be kind of simple. You could patch Log4j or disable logging, but that's probably not such a good idea. You could disable those Jindy lookups by either removing the Jindy class or setting that it shouldn't fetch remote code. Or, for example, you could disable some features like the Java Security Manager. You could disable some features in your code base. And all of those would help you to protect against that security issue. What kind of like made this tricky is that what everybody does is to monitor their applications. They have logs, right? It's kind of unfortunate if your logger then has that security issue and sucks up all of those vulnerable strings and might be potentially exploitable by that. But that's another issue. And somebody made this great map of, am I vulnerable to Log4Shell? And then it's like, am I running any code in the JVM? If no, do I use any third-party tools like a data store or whatever that uses Java? If no, then you're actually safe. Otherwise, you can then go these various paths. Like, I'm using code in the JVM. Do I have Log4j anywhere? Which major version is it? Is it 1 or 2? 1 has its own security issues, which are not so severe. But if you have 2, then you need to check, like, what is the specific minor version. And then you need to check on Java 8, it's a different version, and on Java 7, etc. And then you can work your entire way through that to actually figure out, am I vulnerable or not? Which is really as complex as it looks. And the effect that this had was that a lot of companies were kind of like A, freaking out, and B, also trying to outsource all the work to their vendors. And what happened then, Daniel Stenberg, he's the guy who does curl. What programming language is curl written in? C. And he was getting requests by companies that say like, you have 24 hours to tell us if you're vulnerable to Log4Shell, which is A, a bit ridiculous because it's written in C, and B, also like, oh, you're just a free user downloading the software, and then you expect somebody to answer in 24 hours. But he was complaining on Twitter quite a bit that he was overwhelmed, and he wasn't even using Java. So anybody using Java was having a lot more trouble just keeping up with all the support requests people were sending out. So it was a lot of fun for everybody. And then there was also this drama around Log4j 1, because it still had its own security issues. And I said, like, there are these two camps in the Java logging world, which is almost surprising. It's like, it's really only a handful of people doing all the logging in the Java ecosystem, but they don't get along. And then one group didn't want to patch that, and then the other group forked it into another package, and just this week there was this big discussion if this should even have happened and whatever. So it's always also a people factor to some degree, how the ecosystem evolves. What is quite interesting that if you use tracing in your application to see like what is slow or what is failing, you can actually watch these exploits happen in real time as well. Where you can see, oh, my application is running, and suddenly my application is doing a GET request to this random IP address here, which it probably shouldn't do. That is probably a good indicator that something is off here and you might want to step in. Another thing that's also from our products, like we have the full security suite by now, where you can see like what application is calling what other applications. So for example, if you see like you have your Java application running and that's calling a shell, that's calling another shell, and that's calling wget, that's potentially also not a great pattern to have. Also, if you have these weird child processes, we have actually alerts on those to tell you like, Java is starting a child process that it really shouldn't do or that I have never seen before. And then you can fix that. I don't really want to make that a product demo. If anybody wants to see that in action, I can show you afterwards. Also, I think my colleagues are actually in town very soon, to show you stuff like that. That's the only pitch I'm adding here. Any questions on that part? No? Cool. Then, let's wrap it up. Log4Shell is definitely a major mess, all over the place. And it's probably still somewhere in your infrastructure and you don't know it. It might be, something like this where Log4j on your toaster, and then you're like, no, that's not a thing, but really, are you sure? Because I think the Oracle has always promoting that Java is running on 1 billion devices, or 4 or whatever. And by now, this might be more of a threat than actually advertising. So you might find that in random places where you didn't expect it. what to keep in mind is that the first security issue, that really was a big deal, and that should be fixed. The other three are annoying and should also be fixed, but are on a much lower level. Though I also feel like people were a bit like capitalizing on that big first wave of security issues, and then just to get their name out, like, oh, there's another one. And they were a bit overblowing those, even though they were by far not as severe as the first one. But obviously, if you clean up the first one, clean up all of them in one go. And for most Java developers, December was a rather stressful month, and nobody aged very well then. It's easy to exploit in theory, as I've shown you. In practice, it's sometimes a bit more complex, as you've seen with Java version and Java Security Manager. And there are lots of pieces at play, like, which make it a bit harder to actually say, like, you're actually vulnerable and you can exploit this. It's still a bad thing in your code that you want to find. Is it still a problem? Yeah, just very recently in end of June, I think that was some US governmental organization that was, giving out, these warnings that people attacking systems are very actively looking for Log4j, that it's probably somewhere in the infrastructure, and it's probably something, if somebody managed to get a hold in your network anywhere, they will be looking around for any vulnerable leftovers in Log4Shell, because it's just something that is potentially still waiting to be found in your network. So it is still a good time to try to clean those up. And with that, any final questions? I think we have like 3 minutes or so left. Anybody that added any questions here? No? Yes, please. I'll try to repeat. Or, yeah, shout and I'll repeat. So the question was, how could you counter the hysteria? Yeah, I think if you know that, you could make a lot of money. Or you could also make your life a lot easier. I don't want to say we didn't manage to do that, but it was a lot of work. I mean, the hysteria is just sweeping over you. And I think we had 100 people working over the weekend on Log4Shell, on the first weekend in our case. And then we had, like I said, the support rotation where we had a couple of engineers do nothing else for weeks than reply to Log4Shell things. So I don't think there is an easy fix to that. It's like, I think it's like it's unfortunate that a lot of security issues are not getting the necessary attention. And then there are a few that get all the attention. And it's kind of like the other way, and everybody freaks out about them. And it's like there is no reasonable middle ground to work on that. And I have no idea how to fix that. But I think that's a hard people problem. Yeah. Any other questions before lunch? Otherwise, A, thanks a lot. B, I have a lot of stickers here. If you want to have any stickers, take stickers. If you have any other questions, I'm here for the rest of the day. Find me over lunch or at any time. Thanks a lot.